Top Secret Psi Operative Training Mission. Potential and Kinetic Energy. Mission: understand kinetic and potential energy. Use the help of the PSYOPs team to understand the concepts and prepare for your missions. Tips: remember to beam as you read through the passage below.
To aid you in your quest to defeat the Hive, I've created a new piece of gear for you to utilize. Jump boots. They store potential energy, and once released, they will convert that energy into kinetic energy to allow you to extend your movement and reach new heights.
Thank you, Dr. Watt. The jump boots will definitely give our PSYOPs team the advantage over the Hive in our missions. Could you explain what potential energy and kinetic energy are so that I can relay the information to our team?
Absolutely! All energy can be divided into one of two types: potential energy and kinetic energy. Before I get into the types, let's talk about what energy is. Energy is defined as the ability to do work. Work is a force causing the movement or displacement of an object. Every object has energy, even if it's not moving, or most objects have many forms of energy. People use energy to run, to bicycle, to move cars along roads, to cook food, to light our homes, and to manufacture products.
We need to create enough energy to defeat the Hive.
You will definitely need to use energy to defeat the Hive. However, energy is neither created nor destroyed. The amount of energy in the universe is constant. Energy can move between objects and change into other types of energy, but it is never lost. This idea is known as the law of conservation of energy.
This kind of makes it sound like everything has energy, but can that really be true? What about if something isn't moving, or even alive, like a rock laying on the ground?
Yes, even a rock laying on the ground has energy. Depending on where the rock is located, it could have potential energy. Potential energy is the energy stored in an object because of its height above the earth or shape. It is called potential energy because it describes the potential of an object to do work. For example, if that rock is laying at the top of a hill, then it would have stored potential energy because it is overcoming the force of gravity to remain on the hill. If the rock starts to roll down the hill, its stored energy is now turned into kinetic energy. Greater heights have more potential energy because the increased distance above the earth allows for more time for energy to be converted into more motion. This concept of more potential energy with greater height is gravitational potential energy.
So, is kinetic energy the energy of motion?
You are correct, Nikole. Kinetic energy is the energy possessed by an object in motion. The word kinetic comes from the ancient Greek word kinetikos, which means simply to move. Anytime an object moves, it has kinetic energy, whether it is a soccer ball rolling across a field or the earth revolving around the sun. That rock laying on the ground may not look like it is moving, but it also possesses kinetic energy. It can have heat energy, which is the kinetic energy of the molecules that make up the rock vibrating in place. Potential energy as thermal energy also results from bending or stretching materials like a rubber band or spring. This energy is referred to as elastic potential energy because the change in shape of the object changes the stored energy within. This type of energy is how a lot of switches or buttons work to turn on machines. The jump boots I've created trap air, heat the air to pressurize it, and then release the air in small bursts. This released air creates thrust, which is kind of kinetic energy, just like the heat energy in the trapped air. The work done by the thrust propels Nikole into the air, converting the kinetic energy into gravitational potential energy. Since there is no switch to turn on the jump boots, and neither the air nor the jump boots themselves are elastic materials, there is no elastic potential energy involved. In this diagram, we can see that when Nikole takes off, gases are released, turning the stored potential energy, or PE, from the jump boots into kinetic energy, or KE. This is why the orange KE bar is higher than the blue PE bar. As she gets higher in the air, Nikole's kinetic energy will decrease, and the potential energy will increase as she gains altitude. At the very highest part of her jump, Nikole has traveled as high as her jump boots could send her. She now has a lot of gravitational potential energy due to her position at this highest elevation. Notice that the blue PE bar is now higher than the orange KE bar. As Nikole starts to drop back down, the gravitational potential energy turns into kinetic energy as she moves back towards the ground. Her kinetic energy will be at its maximum just before she hits the ground.
I can't wait to give these jump boots a try. Thank you, Dr. Watt.
Make connections. In each box below, write a connection between the text you just read and either your prior knowledge or something in your life. Reading comprehension questions. 1. Define energy. 2. What is the law of conservation of energy? 3. Compare and contrast kinetic energy and potential energy. Focus question. How is this defined? Complete the first box for potential energy and kinetic energy for the second box. Focus question. How do you increase this? Complete the first box for potential energy and the second box for kinetic energy. Four. Describe how gravitational and elastic potential energy are different. 5. In your own words, explain how energy is converted from potential to kinetic energy in Dr. Watt's jump boots. Make sure to note specific types of kinetic or potential energy as needed to clarify your explanation. Six. In the laboratory, you will be able to improve the axial compressor and upgrade the heating coil for your jump boots. This will increase the stored potential energy. How will this affect the height that Nikole can jump? Explain. 7. Astronauts are able to jump much higher on the moon than they are on Earth. What does this tell you about the gravitational potential energy on the moon compared to the Earth? Explain.